Hello, Dr. King. This is my homework for number 1. The name is to explain how to calculate the position of the end effector use the DH parameter. The tasks of this operation are to explain and design frame, DH table, and post max or end effector. Like this. This is the 3D now. The distribution is interpreted and calculated like this. 1 frame assessment. The logistic have 4 coordinate from frames 0 to 4, with joints between frames 0 to 1, 1 to 2, and 2 to 3, and the end effector is at frame 4. About this frame, frame 0 is the base, origin at the base with z0 vertical. Frame 1 attached after a vertical link of length d2 and rotated by theta 1 around the z0. Frame 2 attached after a horizontal link L2 translation along x1. Frame 3 attached after a horizontal link 3 translation along x2 and rotated by z3 around z2. Frame 4. This is the end actor fellow frame for the tool. For each joint in this picture, like this, the z axis represents the axis of rotation. The x is rotation perpendicular to the axis of rotation. About the derived Hantenberg convention, the derived Hantenberg convention is a standardized method used in robotics to represent the relationship between adjacent links in a robotic manipulator. It simplifies the complex 3D transformations required to describe the positions and orientations of robot joints. Use DH conversion. This is the why use DH conventions. First, to systematically describe the spatial relationship between consecutive links. Second, to deliver the forward kinematicals of robotic arms efficiently. Third, to simplify complex calculations in robotic kinematicals. The determining for DH parameters table. About this part, the DH parameters define the transformation between consecutive frames. Assuming joint 1 is revolute theta 1. Joint 2 is prismatical D2, and joint 3 is revolute third theta 3. Then the left picture is show the DH table. About this table, theta I means rotation about the I subtract 1 to align X I minus 1 with XI. DI means translation along the I minus 1 to bring the origins to the same line. AI means translation along XI to bring the origin together. Alpha I means rotation about XI to align the I minus 1 with the I. About this table, theta I, this theta I, theta 1 and theta 3, this theta 3 are revolute joint variable is like the picture show. D2 is the D2 is the prismatic joint variable, and L2 and L3 are fixed link lengths. Three post kinematical forward. The transformation matrix from frame I minus 1 to I derived use the DH parameters like these forms. Ti I minus 1 equal to T round AI root alpha I train round DI root theta I. By substituting the data from DH table into the transformation matrix and rotation matrix, the transformation matrix can be obtained as like this. Number 1 from frame 0 to 1, this T1. This T1 equal cosine theta 1 minus sin theta 1 0 0 and sin theta 1 cosine theta 1 0 0 0 0 1 D2, and 0, 0, 0, 1. About this matrix, rotation around z0 by theta 1, translation along z0 by d2. And number 2, from frame 1 to 2, this calculation T2 equal 1, 0, 0, L2, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. About this means translation along x1 by L2 by L2. Number 3, from frame 2 to 3, like this T3. T3 equal to cosine theta 3 minus theta sin theta 3, 0 L3 sin theta 3 cosine theta 3, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. About T3 means rotation around z2 by theta 3, translation along x2 by L3. Number 4, from frame 3 to 4. This 4 is the end effector. T4 equal to 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. And we can say T4 is a unit matrix. This identity matrix no additional transformation. Then about the end effector pose, the overall transformation from frame 0 to 4 is like this. T end equal to T1 multiply T2 multiply T3 multiply T4. Then we reply about T1, T2, T3, T4 like this. This T1, T2, T3, T4 calculation equal this T1 multiply T2 equal to cosine theta 1 minus theta minus sin theta 1, 0 L2 multiply cosine theta 1, sin theta 1 cosine theta 1, 0 L2 sin theta 1, and 0, 0, 1 D2, 0, 0, 0, 1. And this T3, this T4. Next, T1 multiply T2 and multiply T3. This two part multiply equal like this cosine theta 1 8 theta 3 minus theta 1 sin theta 1 and theta 3 0 L2 cosine theta 1 8 3 theta 3 and 8 L3 sin theta 1 8 theta 3 cosine theta 1 8 theta 3 0 L2 multiply sin theta 1 and theta 3 0 0 1 D2 0 0 0 1. this T1, T2, T3, this three part multiplies equal, and need multiply T4. Because the T4 is a unit Maxwell matrix, unit matrix. So the T1, T2, T3 multiply and multiply T4 equal to T1 multiply T2 multiply T3. Step 4, add a factor coordinate interpretation. The end factor frame 4 pose is determined by T end. This T end equal cosine theta 1 add theta 3 minus sin theta 1 add theta 3, 0 L2 cosine theta 1 add theta 3 and add L3 sin theta 1 add theta 3 cosine theta 1 add theta 3, 0 L2 sin theta 1 add theta 3, 0 0 1 D2 0 0 0 1. About this add effector, the attitude analysis like this, the rotation part of the homologational transformation matrix, the 3 by 3 3 multiplies 3 submatrix in the upper left corner, like this part, describes the attitude of the end effector in the base coordinate system. About this, first the end effector is rotated at an angle theta 1 and theta 3 about the z axis. And the form of this rotation matrix indicates that the attitude of the end effector is only determined by theta 1 and theta 3. The rotation axis of the end effector is the z axis, because the third column of the rotation marks this is 0 0 1, indicating that the z axis direction is unchanged. This means about this part is the translation part of the homologational transformation matrix. This is the first of 3 elements of the last column. Describes the position of the end effector in the base coordinate system. This part is about the position. Like this, we can say x direction is L2 cosine theta 1 8 theta 3 and L3. Y direction is L2 sin theta 1 and theta 3. Z direction is D2. About this part, we can say the total rotation angle of the shaft is theta 1 and theta 3 too. Like this. Then this is all of my about this homework. Thank you.